Hi everyone, today's topic is points, lines, and angles. This is Unit 1, Day 1 of Geometry. The objective for our lesson today is I can identify and name points, lines, rays, segments, and angles. If you look right here, you'll find our unit progression. That means these are the topics that we are going to cover this unit, ending with our Unit 1 assessment. So today, we'll work on points, lines, angles. Next class, we'll talk about slope, then parallel and perpendicular lines, going into midpoint, distance formula, and the equation of circles. Now, the statement of inquiry is a statement that is written to help us focus on why do we need to know about points, lines, and angles in the larger scope of our lives. So today, we're going to be thinking about math as a language that has specific vocabulary and a grammar structure. In order to succeed in math, we have to become fluent in the language of mathematics. In algebra, for example, we learn how to read and write paragraphs when we solve equations. Similarly, in geometry, there are more symbols that we will learn how to use correctly and fluently. So as an example here, I have an equation that shows how many of us would kind of write out each step to show the correct answer. And we can think about each line as a sentence and all of the lines put together as a paragraph. And the way that we write and have these specific rules in place, for example, the subtracting of the 8 here, the crossing out here, keeping our equal sign aligned, those are all grammar rules in mathematics that we follow so that when you write it, I understand what you're saying, and when I write it, you guys understand, and you guys all understand each other. Similarly, when we do geometry, we're going to be learning a lot of these similar rules, right? What do these letters mean here? What does this symbol here mean, right? If I were to draw this symbol here, what would that mean? We're going to be learning all of these new language and grammar vocabulary so we can understand and communicate better with each other, just like you guys already communicate in English and in Spanish. So to get us started, I really want for you guys to know a little bit more about me. You guys may or may not know this, but I am a Korean American person. And when I was younger, I learned a little bit of Korean. I wish I were a little bit more fluent than I actually am, but I have 2 sentences for you. One is written in English and one is written in Korean. Both of them have the same meaning, right? So in English, I wrote, I like red apples. In Korean, what that would sound like is 나는 빨간 사과를 좋아해요. All right, and that pretty much means I like red apples. If I were to directly translate this for us, the first word here, 나는, means I. The second 2 syllables, 빨간, means red. 사과를 is apples. 좋아한다 is like. And what you guys can see is that the order of our words are a little bit different. And using our specific kind of grammar words, you would say that in English you go subject, verb, adjective, object, right? I am talking about myself. Liking is the verb. The color, red, describes our object, which is the apple. In Korean, our sentence structure is a little bit different. I is still the subject, but then we go adjective, object, verb. And by understanding and knowing these rules, whether you do it intuitively or you have to do it more by practice and learning another language, you come to be able to understand each other, right? If I said, I like red apples, but with a Korean grammar, it would sound a little bit weird and it could get confusing. And so for that reason, we have these rules, grammar rules that we need to follow for mathematics. One of those very common rules is the order of operations, or many of you guys will have heard them as PEMDAS. Take a second and think, do I remember what each of those letters represent? I bet many of you guys do. But as a quick refresher, P is parentheses, then exponents, multiplication, division, addition, and subtraction. And what this tells us is when we see an equation that looks like this, or an expression, we have to follow these orders. You have to do what's in the parentheses first. And then you can do multiplication and then addition and subtraction. All right? And that's the first thing that we're going to be looking at today. So as we go into the first part of our lesson, we're going to talk about the order of operations. All right? And that's kind of the more formal way of saying PEMDAS. So we're going to look at the groupings or parentheses, brackets. Sometimes you'll see things that look like this. It'll be essentially the same thing as parentheses. And then exponents, which I just want to note will also include any of the square roots or cube roots that you might see. Multiplication and division. And if they're multiple, we should be going left to right. And then any addition and subtraction. Similarly, if they're multiple, you'll go left to right. So just as an example, I want to go through how we would do this example all together. First thing that I see is this set of parentheses. And I know that 9 plus 10 is 19. I know that between a parentheses and this number 2 right in front of it, it should indicate multiplication. So I'm just going to put that there. And then we have our 9/3. This is a fraction, but it's also another way of indicating division. So I'm going to keep that in mind. And then write out the rest of it. Minus 8 plus 4 times 3. All right. So groupings, check. I don't see any exponents. I don't see any of these small numbers that are higher up. I don't see any square roots, things like that. So I'm going to move on. I do see multiplication and division. So like we said before, that fraction is a form of division. This is multiplication, and then the 4 times 3 is also multiplication. I know that 9 divided by 3 is 3, plus 2 times 19 is 38, minus 8 plus 12, which is what you get from 4 times 3. Now we just have addition and subtraction all the way through, so I can go left to right. So 3 plus 38 minus 8 plus 12, I'll end up with 45, which is my final answer. Okay? So we did our multiplication and then our addition. Now, I know a lot of you guys in algebra worked really, really hard learning how to solve equations. And when we solve equations, we do the order of operations, but in reverse. All right? So when we look at it, we have to start by, okay, combine any like terms. So do I see anything that's the same on one side as it is on the other side? And then we'll do, is there anything being added and subtracted? We're going to do the inverse operation of those. Is there anything being multiplied or divided? We'll do the inverse of those. We'll undo any exponents, and then we'll undo any groupings or parentheses or brackets and things like that. So here, I'm going to start off by looking at just what I have on the left side of my equation. The negative 3d plus 5d minus 4. Hopefully y'all remember that like term means they have the same variable with the same exponent. Here we just have the letter D, which means the exponent, there's an invisible 1 right here, there's an invisible 1 right here, okay? They are like terms. Negative 3D plus 5D, I can combine and simplify to get 2D minus 4. All right, now I'm gonna look at my right-hand side. I have 11 and I have a negative D, right? My 11 doesn't have a variable. D is a variable. They are not like terms. I cannot combine them. So I'm just going to bring them down. Now what I want to do is undo any subtraction or addition. And I see already here 2 things that are being subtracted. So This is my own personal preference. You don't have to do it that way, but I find the largest positive number with my variable. So in this case, it's a 2D. And then I look at my other side, I have a negative D, right? So I know it's being subtracted. The opposite of subtracting, because we have to undo it, is to add. So I'm going to add a D on this side, add a D on this side, right? Negative D plus D becomes 0 Ds. I have no Ds left over. I'm going to bring down my 11 over here. 2D plus D, I end up with 3D minus 4, which I will also be bringing down, okay? Now, I have all of my variables on one side. Then, again, we're isolating that variable. So, we have a minus 4. The opposite of a minus 4 is to add 4 to both sides. Negative 4 plus 4 becomes a 0, so they cancel out. We don't have any more. 3D we bring down equals 15. Now we don't have any addition or subtraction, so we have to go on to any multiplication or division. When we have a number and a letter side by side, we know that they're being multiplied. All right, so in order to get the D all by itself, we have to do the inverse of multiplication, which we know is division. So I'm going to divide by 3, and we end up with D equals 5. And that is our final answer. Okay, luckily here we didn't have to do any exponent work or any undoing of parentheses. Now I want to move us from algebra into geometry. And this will probably be somewhat familiar to some of you guys. So hold on to what you know already, what seems intuitive. There's a place for all of that. And then be ready to accept some new information about things that you think and feel like you already know a lot about. All right? Well, let's start with what geometry and mathematicians will define a point to be. When people talk about a point, they're indicating a location. And they're indicating a location, but it doesn't have any size, right? A lot of times we'll draw it as if it has a certain size, like that little circle. But mathematically, it's just to tell us where it is and not telling us how big something is. We always indicate a point using an ordered pair with the letters X and Y, representing our x-axis and our y-axis. It is like the directions that we start at the middle, and then we go this many units left and right, and then this many units up and down. All right, so for example, if I wanted to indicate this point right here, I'm going to give it the letter A. I know that if we're looking at our x-axis, we would have to go over 1 in the positive direction, and then we would have to go up 4 in also the positive direction. All right, so point A here, we would notate being 1, 4. And that would tell us we have to go over 1, up 4. And that's our specific location. All right, that's how we indicate points. When we talk about a line, it is represented by a straight path that extends in 2 opposite directions forever. All right, this is one of those geometry terms where you use the word line every day, but it has a very specific definition in geometry that might be different from your everyday definition. And will also be different from maybe a definition you learn about in your art class. So it's kind of important to be able to understand that the same word might have 2 or 3 definitions. So in math, it talks about a straight path and it goes in opposite directions forever. It has no thickness and it contains an infinite number of points. So for example, if we had a point right here and we had a point right here, and I wanted to connect those, I would draw that line, right? It's a straight path, it connects those points, and it would go on forever, which is why I draw those arrows. And the arrows are important because it tells me and it tells you guys that it is a line that goes in both directions forever. And we'll talk about in a second what happens if maybe we don't want it to go on forever. Now, lines are considered collinear when they lie on the same line. So here we have this point, we'll name this point A, and this point B, and then we can have this point here, C. And we'll say because they're all on the same line, A, B, and C are all collinear. You can notate a line using a small line with arrows on both sides over any 2 points along the line. So right here we have AC, CB, AB, right? Any combination of those is fine. And you just need to make sure you have those little arrows on top and then write 2 points. All right. It is just one of those rules that we only use 2 points, right? So it would be improper. We would not want to write A, C, B. It's too much information that is unnecessary and is improper, okay? So 2 points, make sure you have the arrows. Now let's talk about array. Array is a portion of a line, and it consists of one endpoint. And then it's that endpoint and then all of the points on the other side of that endpoint. It can be notated by a line with one arrow over the endpoint. So here, let's say we can draw another line from here, going on in that direction. And it starts at that initial point, but then goes on forever. So we're gonna draw that arrow to indicate this is going forever to the right. But it starts, right? I have an endpoint here at -3, 2. We're gonna call that point A and this point B. You'll see that my endpoint doesn't have that arrow. So make sure you're matching it up, A and then B, right? Where am I starting, right? And then I'm gonna go through which other point. Same thing as with a line here that we're only using 2 points. When we indicate rays, we only need 2. And then lastly, we want to talk about a line segment. A line segment is a portion of a line that consists of 2 endpoints and all of the points in between them. So you can notate a line segment by using a small line, no arrows over 2 of the endpoints. So here we have this point, and let's go with this point here. And then draw that line in between them, like that. Okay, so here we have A, B, and let's put a letter C right here as well. In order to indicate that entire line segment, we would have to use A, B. You could also say BA. The order of those don't actually matter because they're both endpoints. But what I want you to be careful of is notice that the line segment AC, if you were to write AC, is different from our line segment AB, right? Because those letters always indicate endpoints. All right. The length of those line segments are different, and so we have to be very specific in how we're notating each of these segments. All right. So the first question here I want to go over together, and then there's another question that I want you to spend some time trying to figure out on your own. So, given the diagram, answer each part of the following questions. Here it asks us to identify each of the distinct points. Now, what you'll notice is when we talked about a point up here, we said that we use a letter and then an ordered pair. But you'll find in this question, we don't have a coordinate grid, so it's not going to be possible to give them an ordered pair. That's okay. We're just going to be looking at each of these letters. So we have points, E, F, and G. And we can just list them like that. Name all distinct lines. Now, lines is a straight path and goes forever in both directions. But if we look really carefully here, we'll see there's an arrow there, but we don't have an arrow on this side with our E. which means there's actually no lines in this diagram, right? Because the definition of a line is that it extends in two opposite directions forever. And this one, it has a very clear stopping point. So there are no lines. Now it asks us to name all distinct rays. So we can have a ray that starts at E, and then it goes through G, right? So it's kind of what we see as the entire ray here. And then we also have this little ray right here going from F to G. And those are our two distinct rays. But some of you guys might be asking, well, what about EF? What about ray EF? And what you'll find is ray EF and EG indicate the exact same ray, right? Because it goes through point F, it goes through point G, no matter how we're naming it, it is the same ray. So here you would put either of those, but we recognize they're the same one, so you only need to put one or the other, okay? And then lastly, it says to name all distinct line segments. And here we have three distinct line segments, right? We have this section, we have this section, and then the entire section. Again, the order of our endpoints don't matter, so we have EF, FG, and EG. Those are three distinct line segments. So take a second and try this checking for understanding on your own. Now the last geometry vocabulary word we're going to be learning about today is an angle. And you form an angle when you have two rays that share an endpoint. So if we look right here, we have this shared endpoint B and array BA and array BC, all right? And this B, because it's the endpoint that they share, has a very special name called the vertex, all right? Now we can name an angle in three different methods, which can be kind of confusing, so we just have to go with it here. One method is to use the letter by its vertex, right? In this case, it would be the letter B, so we can use this angle symbol like that, and then the letter B, which is a vertex. You can also use a point on each ray, so there's a point A on one ray, the vertex, and then a point on the other ray, C, and you can list all three of those so that the vertex is in the center, right? So you're kind of creating a sandwich there, A, B, C. And then sometimes there'll be a little number to indicate the specific angle, and you can also use that number, all right? I will say that whenever it is possible, whenever you have enough information, I am always going to ask you guys to use this method, the one where you use all three letters. The reason why is because I imagine some of you guys have been in a class where there have been multiple Johns, for example. Well, sometimes just saying John is enough, right? If you're with your friends, if you're in a class with only one John, that's enough, it's specific enough. But sometimes if you have multiple Johns, then you need to be more specific and use their last name. And that's what this green method is like. It's using the last name to be more specific. Sometimes just using the vertex is enough, but as we get more complicated, we'll have pictures that look like this, and B indicates this point right here, but if you just write angle B, you can be talking about 4 different angles there, and that's really confusing. So whenever possible, use this method. The reason we talk about all 3 of these is if you see it in a question, you have to be able to identify what they're talking about. All right, so here we're going to take a look at our second question. What are all the distinct names for this angle? So we're always using this little symbol, the angle symbol. We know that y is our vertex, and it's always going to go in the center. And then we can go x, y, z. You can also use z first, but y is still in the center. And then you wouldn't write this if you didn't have to, but if it were in a question, you would be able to recognize that angle y is also talking about this angle as well. You can see there's no number 1, 2, or 3 or anything like that. So these are your 3 distinct names for the angle. All right? Try out this next question on your own. And then I want you to take a little bit of time to go through all of the notes that you've taken so far. And really think about what are the important pieces, what are the parts that I didn't know from before, and write it out in this summary here. My expectation for the summary is that it is 3 to 5 complete sentences. I also ask that you really think about the connection to our statement of inquiry, right? What is that larger picture that I've asked you to think about? And practice using the specific vocabulary, all right? So statement of inquiry. And use specific vocabulary, especially the vocabulary that we introduced in this lesson. All right? Thanks you guys for listening. Bye.